Imagine for a moment you have the power to control time itself. What would you do? A riveting thought, isn't it? This concept, this ability to manipulate time, is not a new one. It's a theme that has been explored in countless novels, movies, and TV series, captivating the human imagination for ages. The allure of time control lies in its vast implications on reality. After all, time governs everything around us. It determines the rhythm of our lives, the ebb and flow of our existence. So, the prospect of manipulating this intangible force is both exhilarating and terrifying. Imagine being able to rewind the clock and rectify past mistakes, or fast forward to peek into the future. Or perhaps, you might want to freeze a precious moment, holding it forever in an eternal present. The possibilities are endless, and therein lies the fascination. But what about the consequences? For every action, there is a reaction, a ripple effect that spreads across the tapestry of reality. If you change something in the past, it could drastically alter the present, a concept popularly known as the butterfly effect. Similarly, knowing the future could create a paradox, a conflict between what is and what could be. It's a delicate balance, one that could easily tip into chaos. Then there's the question of free will. If time can be controlled, do we truly have the freedom to make decisions, or are we simply puppets dancing to the tune of a predestined script? It's a philosophical conundrum that adds another layer of complexity to time control. But how close are we really to controlling time? Well, our understanding is still in its infancy, and the road to discovery is fraught with challenges. However, that hasn't stopped us from delving into the mysteries of time. In the realm of quantum physics, for example, we've stumbled upon mind-bending experiments that hint at the malleability of time. But how close are we really to controlling time? Let's delve deeper into this intriguing subject. To understand time control first, we need to comprehend what time really is. It's a concept that's as common as air, yet as elusive as a shadow. We measure it, we live by it, but do we really know what it is? Let's delve into the scientific perspective. According to Einstein's theory of relativity, time isn't a constant, it's a variable, connected to the fabric of the universe itself. Picture the universe as a vast, flexible sheet. Massive objects like stars and planets cause this sheet to curve, creating what we perceive as gravity. But here's the kicker. That curvature also affects time. Near a massive object, time slows down. This is known as time dilation. Then, there's the curious world of quantum mechanics. Here, time takes on an even stranger role. In the quantum realm, particles can exist in multiple places at once until observed. This leads to fascinating theories like superposition and entanglement. Some physicists even suggest that time might flow in multiple directions at the quantum level. But wait, it gets even more interesting. Time is also linked with the second law of thermodynamics, which states that the total entropy, or disorder, in an isolated system can only increase over time. This provides a direction to time, known as the arrow of time. But why does time have an arrow? Why doesn't it flow backwards? These are questions that continue to puzzle scientists. As we journey from the realm of relativity, through the quantum world, and into the laws of thermodynamics, it becomes apparent that time is an integral part of the very fabric of the universe. It's intertwined with space, matter, energy, and even entropy. The concept of time is far more complex than what meets the eye. So, can we manipulate something so fundamental? Well, buckle up, because we're about to explore the thrilling and mind-bending world of time control. Manipulating time isn't as easy as flipping a switch. There are significant challenges and limitations. Now let's delve into the conundrums of our current understanding of time control. First, we must consider the energy requirements. According to Einstein's theory of relativity, bending time would require a substantial amount of energy. As a matter of fact, it's speculated that to open a stable wormhole, a theoretical passage through space-time, we would need an amount of energy equivalent to that of an entire star. This is far beyond our current technological capabilities. Second, the paradoxes. The classic example is the grandfather paradox. Imagine you travel back in time and accidentally prevent your grandparents from meeting. This would mean you were never born, but if you were never born, how could you have traveled back in time in the first place? Paradoxes like these present significant challenges to the concept of time manipulation, and as of now, there are no universally accepted solutions. Third, the unknown consequences. We must consider the potential repercussions of meddling with time. Even seemingly minor changes could have far-reaching and unpredictable effects. This is often referred to as the butterfly effect, where a small alteration in the past could drastically change the future. Lastly, our understanding of time itself is still evolving. Time is a fundamental part of our universe, intricately woven into the fabric of reality. Yet there's so much about it that we don't understand. Is time linear or cyclical? Is it a dimension like space or something altogether different? These questions continue to perplex scientists, making the manipulation of time an elusive goal. Despite these challenges, scientists have made some intriguing discoveries that hint at the malleability of time. As we continue our journey into the depths of time, we must remember that the road is fraught with mysteries and challenges. But who knows? The answers to these riddles might just be around the corner. After all, time, as they say, will tell. Quantum physics has given us some fascinating insights into the nature of time. Let's journey through the realm of the minuscule and the mind-bending, where the rules as we know them seem to blur and warp. You see, in the world of quantum physics, time doesn't always behave like the steady, forward-marching entity we're accustomed to. It's more like a river that twists and turns, speeds up and slows down, and sometimes even flows backward. Consider the delayed choice quantum eraser experiment, a mind-boggling demonstration of time's malleability. In this experiment, particles of light, or photons, are made to choose their behavior after they've already acted. Yes, you heard it right. This experiment seems to show that actions in the present can influence events in the past, defying our conventional understanding of cause and effect. Then there's the concept of quantum entanglement, often referred to as spooky action at a distance. Two particles can become entangled, meaning their states are linked. Change the state of one particle and the other changes instantly, no matter how far apart they are. This suggests that time and space may not be as rigid and absolute as we once thought. And let's not forget about the famous double-slit experiment. This experiment demonstrated that particles can exist in multiple states at once, only deciding their final state when observed. This experiment has been interpreted by some to suggest that the future can affect the past, further challenging our understanding of time. These tantalizing experiments and discoveries hint at a universe where time is more flexible than we ever imagined. They suggest that time, like matter, may be something we can manipulate and shape. They push the boundaries of our understanding, inviting us to question, to explore, and to marvel at the mysteries of the cosmos. These experiments reveal that our understanding of time is still evolving, and the idea of time control may not be mere science fiction. The power to control time may seem like a far-fetched idea, but the journey of discovery is just as exciting. We've delved deep into the concept of time manipulation, its implications on our reality, and the consequences that could follow. We've unraveled the complexities of understanding time, its fluidity, and our current limitations in trying to control it. Theories of time, from the ancient to the modern, have always fascinated us, pushing us to question, to probe, and to challenge our understanding. As we've seen, our current understanding of time is still limited, and the challenges to manipulate it are significant. Yet these roadblocks have never deterred us from seeking, from exploring, and from pushing the boundaries of our knowledge. We've traveled through mind-bending experiments in quantum physics that hint at the malleability of time, showcasing key moments where time seemed to behave unexpectedly. These instances spark wonder and curiosity, inviting us to delve deeper, to question more, and to continue the journey of discovery. Remember, every great discovery started with a question. Every breakthrough was once a hypothesis. The power of curiosity and exploration is immense. It is what propels us forward, what ignites our imagination, and what expands our understanding of the world around us. It is at the heart of every scientific endeavor and every quest for knowledge. As we conclude this journey through the concept of time control, let it serve as a reminder of the power of curiosity and the importance of exploration. Let it inspire you to question, to seek, and to discover. Let it remind you that the journey of discovery is just as exciting as the destination. If you enjoyed this journey through time, explore more mind-bending topics on our channel. There's a universe of ideas waiting to be discovered. So let your curiosity lead the way. Don't forget to like, share, and subscribe to keep your curiosity ignited.